Good morning, ladies and gentlemen, and welcome to the United States Air Force Test Pilot School Space Test Course 23-1 graduation. I am Colonel Sabrina Pabon, and I have the honor to serve as Commandant of the United States Air Force Test Pilot School. My co-host this morning will be Second Lieutenant Josh Barraclough and Major Sean Philly McLean, the class leader for 23-1. Ladies and gentlemen, please stand for the national anthem and the invocation by Chaplain Jay Clark.
Would you all join me in a moment of prayer? God of all power and might, we gather today in joy to celebrate and honor this amazing class of Space Test Fundamentals graduates. We're grateful for each graduate's commitment to excellence and bravery to test. My prayer for each student, each teacher, each leader is that all parties involved realize the benefit of the work they've done, and that for generations to follow, their work will continually be incorporated into the greater Space Force mission. As they each proceed, may they do so with the satisfaction of a job well done and with a restful and confident spirit. Continue to bless the work of their hand as they can commit to continually serve. Amen.
Thank you, Chaplain Clark. Ladies and gentlemen, please be seated. I would like to start by recognizing a few of our distinguished guests. Please hold your applause until they have all been introduced. From the United States Space Force, Dr. Joel Mosier, Senior Level Executive, Director of Science, Technology, and Research for Headquarters United States Space Force. Dr. David Hazelton, Director of Engineering, Space Sensing, Space Systems Command. Colonel Philip Verocco, Commander, Space Delta 5. Colonel Tony Perez, Chief Strategy and Integration Group Office of Policy and Strategy, the National Reconnaissance Office. From the Air Force Research Laboratory Operations Directorate, Dr. Todd Venema, Division Chief Test Management Division. From the Air Force Test Center, Major General Evan Dertine, Commander. And from the 412 Test Wing, Colonel Matthew Kaspers, Vice Commander. Chief Master Sergeant Jeremy Swistak, our Acting Command Chief. And finally, from the United States Test Pilot School, Dr. David Van Hoy. I'm all over the place this morning. Sorry, guys. Mr. David Van Hoy, Technical Director, and Dr. Andy Freeborn, our Director of Special Programs and Space Test Court Director. And finally, Mr. Dallas Smith, my husband. Thank you. I would also like to extend a very warm welcome to the family and friends, visiting commanders, and also everyone that is watching virtually from Class 23-1. Thank you all for taking the time to celebrate with us this morning. A special thank you to those people who organized this event, the graduation committee from the Space Test Course 23-1, and the base multimedia and public affairs teams. The development of the Space Test Course has been a multi-year effort, and we are excited that we continue to evolve this course and meet the United States Space Force needs to produce critical thinking test professionals to conduct that full spectrum test and evaluation of space weapon systems. The students have completed an extremely challenging 5 months, and this morning is the culmination of their efforts. Thank you again for joining us in person and virtually to recognize these accomplishments. Major Sean Feely McLean will now announce the guest speaker for 23-1. Sean, please join me at the podium.
Thank you, Colonel Pabon. It truly is an honor to get to introduce the guest speaker for today's graduation event. Dr. Joel B. Mosier is a senior-level executive in the United States Space Force within the Director of Science, Technology, and Research Department. He serves as the central lead for All Science and Technology Matters for an organization that comprises approximately 17,000 space professionals worldwide and manages a global network of satellite command and control, communications, missile warning, and launch facilities. In this role, he develops long-term military requirements for the Space Force and interacts with other principals, operational commanders, combatant commands, acquisition, and international communities to address cross-organizational science and technical issues and solutions. Dr. Mosier represents United States Space Force science and technology on decisions, high-level planning, and policy, building coalitions and alliances throughout the United States government, industry, academia, the international community, and other scientific and technology organizations. Dr. Mosier entered government service in 1992 with the United States Air Force. Prior to this assignment, he was Chief Space Experimentalist of the Air Force Research Laboratory Space Vehicle Directorate. In that role, he was responsible for managing Air Force Research Laboratory, also known as AFRL's, $40 million per year investment in research and development related to the development of experimental satellites and payloads, and conducted a team of 100 engineers and scientists at Kirtland and Holloman Air Force bases in New Mexico, all working to develop cost-effective ways to assemble, integrate, test, and fly novel spacecraft and systems, and to demonstrate new concepts for DoD systems and missions. His area of specialization relates to space control and remote sensing, understanding the natural and man-made environment, space environment, and developing forecast tools for warfighters, theater battle commanders, and other decision makers to mitigate risks. Dr. Mosier has more than 30 years of space science, engineering, management, and financial experience working space and ground systems for the DoD. In addition to the Integrated Experiments Division, he served as chief of the Battle Space Environment Division and led the laboratory's Space Weather Center of Excellence and was a scientist at the National Solar Observatory at Sacramento Peak. Before coming to AFRL, Dr. Mosier worked at the Air Force's Radar Attenuation and Scattering Facility at Holloman Air Force Base, where he developed measurement and analysis techniques to study the radar cross-section of low observable aircraft and technology. Prior to that, he worked for the Army's Atmospheric Sciences Laboratory, where he developed techniques to quantify the effects of natural and man-made battlefield obscurance on electro-optical sensors. Dr. Mosier, the floor is yours, sir.
Well, thank you very much, Sean. That made me feel old. Thank you. But it's a pleasure to be here, and it's an honor to be invited. Thank you, Sean, for inviting me to come to this. What a pleasure to be here. What a great place, what a great venue to be here. And I'm just honored, and congratulations to all you've done. You know, test is one piece of a spectrum that starts with research and development and test and evaluation, so-called RDT&E. And that's a long process. It's a long and very complicated process. And some of the things in this hangar tell that story. The Bell X-1 there, you know, how long did it take from Orville and Wilbur demonstrating flight to the point where we could go Mach 1? And then develop that as a military capability. Sometimes going from, you know, the laboratory where you first detect a new phenomenon and you're exploring some new discovery to where you operationally accept something on orbit. That can be 20, 30, sometimes more years. And that's why we tend to think very long-term in my job, you know, because thinking about how we look to technology that really may not be fielded for several decades in the future. If you want to be fast and agile in that future, you better be thinking about those technologies today. So my job as Chief Scientist of the Space Force is a lot of strategic foresight and thinking ahead. And I'd like to give you a couple of examples of that long-term vision, because I can guarantee you one thing, the future is not predictable. We cannot know the future. There's just no way to do it. And even the best futurist you can find does not have any crystal ball that's any better than the rest of us. The best we can do is prepare for a wide variety of possible scenarios in the future. And the more of those that we prepare for, the better we will be when we get there at that time. But I can guarantee whatever the future brings, especially in space, it's going to be full of amazement and chaos and disruption, and we need to be prepared for that. So let me give you 3 examples from history first before I start talking about the future of some good and bad examples of the use of strategic foresight. For the first one, I'd like to take you back to the early months of 1939, before World War II. If you were a betting person at that time, you would look at the situation, especially with the rise of the Nazis, and you'd see things like, well, they have U-boats. They're sinking Allied ships in the Atlantic faster than we can build them. They have the Luftwaffe, arguably the best air force at the time, with very long range at the time. Their scientists had just discovered the seedlings of nuclear fission and had in their sights the most dangerous bomb in the world. If you look at all those things, you might think pretty dystopian about the future. In fact, Winston Churchill later that year gave a very dystopian speech about how the Great Britain was going to be descending into a very dark, deep staircase. Didn't look good at all. But one of my favorite characters from history is Vannevar Bush. He was a visionary. He saw that. He saw that very dystopian future and the things that were out there. And he went to President Eisenhower at the time and said, we have something we need to worry about here. We need to have technological acumen to be able to compete with this. So he argued for things like using government funding to fund basic research, and he established the Office of Scientific Research and the National Science Foundation, engaged the world's best academics in solving some of these complicated problems. He also founded a little company called Raytheon and developed radar that was able to detect those U-boats and kind of negate some of that. He developed early seeds of RF navigation, what we call GPS today, and was able to combat the Luftwaffe by having even longer legs and be able to do navigation with the B-23 Raiders. And then he went to the president and said, we need to worry about this nuclear weapon thing. We need to have a program. And convinced Roosevelt to spend a huge fraction of our national treasury on the Manhattan Project to get to the technical acumen and the ability to beat that. There's a visionary that took action, saw a very negative future, but also saw a positive future and drove the decisions towards that positive future. So he's one of my heroes in this regard, very visionary. Let me give you a second example, and it's not a bad example, but in April of 2001, this was President George W. Bush. Donald Rumsfeld was the Secretary of Defense, and it was time for the 2001 Quadrennial Defense Review, the QDR. And for those of you who don't know, that's every 4 years Congress asks the Department of Defense to do a broad-ranging study of what is the structure we have and how does that meet the threats that we see coming. And in April of that year, 2001, Rumsfeld sent this memo to the president that said, this is a hard problem. And he had just run across a guy wandering the Pentagon. His name is Lynn Wells. He wandered the Pentagon for many years, who had written a little bullet background paper about the 20th century. And I encourage you to Google this. It's in the Rumsfeld archives. You can Google the Lynn Wells memo to Rumsfeld. And I'll just quote from a little piece of it. And again, he's talking about the 20th century. He said, if you had been a security policymaker in the world's greatest power in 1900, you would have been a Brit, looking warily at your age-old enemy, France. But by 1910, you would have been allied with France, and your enemy would be Germany. By 1920, World War I would have been fought and won, and you'd be engaged in a naval arms race with your erstwhile allies, the US and Japan. By 1930, naval arms limitation treaties were in effect, the Great Depression was underway, and the Defense Planning Standard said no war for 10 years. 9 years later, World War II had begun. By 1950, Britain no longer was the world's greatest power. The atomic age had dawned, and a police action was underway in Korea. 10 years later, the political focus was on the missile gap, and the strategic paradigm was shifting from massive retaliation to flexible response, and few people had heard of Vietnam. By 1970, 10 years after that, the peak of our involvement in Vietnam had come and gone. We were beginning detente with the Soviets, and we were anointing the Shah as our protege in the Gulf region. And it goes on throughout the 20th century, but you can see every 10 years, something is changing dramatically. The final bullet of his thing is all of which to say that I'm not sure what 2010 will look like, but I'm sure that it will look very little like what we expect. So plan accordingly. That's tough to do. And it's ironic that memo by Rumsfeld to the president was in April of 2001. What happened just a few months later? Had the 9/11 tragedy. Since that time, we've had the second Gulf War in 2003, the rise of YouTube in 2005, the invention of the iPhone in 2007, the Arab Spring in 2010, the annexation of Crimea in 2014, Brexit in 2016, the COVID pandemic, withdrawal from Afghanistan, war in Ukraine. None of that was foreseen by this letter in 2001. So strategic foresight is hard. And I say again, you can't predict the future. One more example from history, and this one hits very close to home. This was from General Bernie Schriever. In April of 1957, April 24th of 1957, he gave a speech to the Air Force Office of Scientific Research. It was their first astrodynamics conference ever. So again, this is April of 1957. What happened in October of 1957? Sputnik. And what he said, I'll just read a part of his speech because it's beautiful. He says, "A word is necessary on the relationship between military need and scientific feasibility in space technology. In the long haul, our safety as a nation may depend on our achieving space superiority," a term that he coined. "Several decades from now, the important battles may not be sea battles or air battles, but space battles. And we should be spending a certain fraction of our national resources to ensure that we do not lag in obtaining space supremacy. Besides the direct military importance of lunar expeditions, our prestige as world leaders might well dictate that we explore even interplanetary flight when the appropriate technological advances have been made and the time is ripe. Thus, it is indeed unfortunate that technology advances required in support of military objectives can, in large part, directly support these more speculative space ventures." I think that's pretty dang prescient in 1957, before Sputnik came up, thinking about landing on the moon, interplanetary flight, space battles. But there's one thing I'd like to point out. He said in 1957, all of that would happen several decades from now. That was 6.5 decades from now. Someone could argue that's more than several. So what happened there? I'm not to diminish all of the great accomplishments that have happened in space since that time, because there has been a lot. But when I was this tall, thinking about the year 2023, we should be flying around in our jets and cars and traveling on the spaceship Enterprise by now. What the heck? Well, there's something known to futurists as, it's called Amara's Law, named after Roy Amara, who founded the Institute for the Future. And it says that humans tend to overestimate the effect of a technology in the short run and underestimate it in the long run. And that's what I'd like to talk a little bit more about. Why is that? Humans are pretty good about thinking about the future, but we think kind of linearly. We see how things are evolving around us, and we can project that into the future, sometimes to our detriment. Henry Ford, when he asked, I'm not sure this is a true statement from Henry Ford, I think it came from somewhere else, but he said, if I had asked the public what they wanted, they would have said faster horses. Because it's hard to see the disruptive change that could happen with a new technology. technologies tend to be exponential. They grow on each other. One technology begets another, and so they grow very quickly. Our human brains are a little better at thinking linearly. So if you think about that, in the short term, an exponential curve grows very slowly, and actually our linear expectations exceed that. And so we're disappointed. Think about things like fusion energy or quantum computing, things, colonies on Mars. We've been talking about these for 30 years. How come they haven't happened? But I tell you, once the technology goes vertical, so to speak, that's when you get into this realm of amazement and chaos and disruption. And folks, we are there in space. If you just have to pick up any news feed or article and see the amazing things that are happening in space today. And it's all being enabled by things like low-cost reusable launch. The cost to get a kilogram of mass from Earth to low Earth orbit has gone down 2 orders of magnitude in just the last 20 years. Microelectronics are getting smaller. Commercial ventures. There was you saw it on CBS News this morning. There was a piece about commercial ventures to the moon. They're expecting $100 billion commercial market. So there's for the first time since Apollo 17, we will have American hardware touching down on the moon, and it will be commercial hardware first. It will be the NASA Artemis program. So a lot of chaos and amazement and amazing things are going to happen in the future. And what I would like to implore you all to do is to think about from the perspective of test and space test. What does that mean? How do we get ahead of that? How do we see that future, prepare for the chaos, embrace the disruption, and lead that? And that's, as you go back to your jobs, now that you've completed this course, to think about what that could be. Let me just leave you with a little bit of a story set in the future, the near future. So, the chief of space operations, General Saltzman, has a speechwriter. Actually, I just learned he has several speech writers. I have to come up with my own stuff. I don't know what that's all about. But, of course, he gets to talk about what his commander's intent is, what message he wants to convey to whatever the audience is, whether it's the public or Space Force guardians or Congress. And a speechwriter turns that into an eloquent speech. Now, I don't know this is true, but I would expect it's certainly possible that the speechwriter could go to ChatGPT and get a little bit of help in maybe structuring or thinking about some novel ways to think things. I actually encourage that. I think that's great. But let's say that happens, that goes on, and as these large language models get better and better, pretty soon the speechwriter becomes obsolete. Why do you need a speechwriter when the CSO can just input all that information in and get an eloquent speech just right out? So that happens. I think that could happen. My question to you is, how do you test that? How do you know that speech is not biased, that it's adequately representing the intent of the commander, that it's not being manipulated, that it's not releasing any classified material, all of the things that a human would normally do? That's a new era of test. So let's take that just a little bit further. So a few years later, we are working on getting artificial intelligence into our space situational awareness, our ISR missions. We incorporate them into war games. They're developing courses of action for us. At some point, we're going to have digital guardians because they're helping us, sitting alongside us, doing the jobs that we do. We might even, at some point, give them authority and rank. Think of that. I call him Lieutenant Digi. So Lieutenant Digi is proven and has participated in lots and lots of war games and exercises and training right alongside his human counterparts. Over and over again, he's able to come up with the right answer faster. He's competing against adversarial AI, digital agents, getting inside the OODA loop of the adversary, and he gains in rank, and pretty soon he's barking out orders to human guardians. How do you test that? How do you know that that's reliable? How do you know that it's not going to go rogue, or that it's going to violate the laws of warfare or the morals or ethics? This is a new kind of test, but I can guarantee it's not that far off. This is something that we need to think about. So I just leave you with the idea that test is a part of a long-term thinking, long, complicated process. And if we're going to be fast and on the edge, we need to be thinking now about what the future is going to be. So thanks again and congratulations.
Dr. Mosier, on behalf of the Space Test Course Class 23-1, we would like to present you with this token of our appreciation.
Thank you very much.
Also, we have a swag. Okay.
It is now time to recognize the top individual student performers from Class 23-1. The students have worked very hard these last few months, especially, I believe, in astrodynamics. So 4 students, though, have stood out and really risen above as distinguished graduates from this class. When your name is called, please stand to be recognized. First Lieutenant Austin Esquivel. First Lieutenant Adam Ward. Captain Jacob Lutz. And Major Joshua King. Congratulations and well done. Thank you. I would now like to invite Major McLean to deliver his class leader address. The class leader is responsible for leading within and for being that conduit of information flow between the students and the staff at the school. Major McLean had the privilege of doing all of this while also being a student. Major McLean, on behalf of your classmates and the staff at Test Pilot School, thank you for all of your leadership and dedication the past few months. Please join me on stage for your class leader address.
Thank you, Colonel Pabon. How's everybody doing today? Everybody's had caffeine? Preferred caffeine intake? All right. Good morning, everyone, and thank you again for attending either in person or virtually via the live stream. I am Major Sean Philly McLean, or Filibuster, if you're not into the whole brevity thing. I am the class leader, also known as the Senior Ranking Officer, or SRO, for Space Test Course Class 23-1, the Nomads, and it is my honor to speak to you for a few minutes today, though I'm not sure how anything I'm going to say can compare to what Dr. Mosier just talked about, but I'll try. When I was notified by Sonic, the course director, that I was going to be the SRO for this class, I admit I wasn't surprised. Excited, but not surprised. My application had included a waiver for being a year over the desired maximum time in service. At 15 years in service, 16 next week, I am what my younger and more energetic classmates might refer to as seasoned or experienced to my face. I remember the first few days of class when everyone was still getting to know each other and I was figuring out who was going to be leading our class study sessions. It quickly became apparent that we had some truly talented and brilliant individuals in terms of both past accomplishments and future opportunities, and I'd like to take a minute to highlight just a few of them. We have a future detachment commander. Quite impressive considering this person pinned on captain only a year ago. We have a Fulbright scholar, Oxford to be specific. We have someone on the U.S. women's rugby team. Who knows, she may even be a general, or a doctor, or an astronaut someday. But enough about Kelsey Klepto O'Brien. I should probably talk about some of the other amazing graduates. We have a PhD candidate, Ryan Zodiac Reddig, whose encyclopedic knowledge is exceeded only by his Wikipedic knowledge. 2 subject areas in particular have stood out during our time with him. He's the only guy I know who has the requisite knowledge to be certified as both a CPA and a doula. It turns out my roommate, Chris Poppy Peters, is an amazing chef. He is so good at everything he makes. The entire class has already told him we can't wait to visit his restaurant if we're ever in Hawaii. We have a vegan, which isn't Kenny's most defining adjective, but it's usually the first. No, it takes many interactions to truly appreciate the multifaceted, or better yet, multidimensional being known as Kenny Lotto Ehrenberg. We have a Space Force supercoder, Evelyn Davis, a true cyber warrior and quite deserving of her call sign, Titan. We have an entrepreneur, Helen Stix Jancher, who enjoys creating and selling swag almost as much as she enjoys traveling and watching Ted Lasso. I could go on for everyone, but I think you get the idea. Everyone in our class has contributed in some way towards enriching our STC experience. Speaking of our STC experience, I have prepared a few graphic representations of our 5-month journey together to provide some insight for our live and virtual audience. Some of you may be familiar with these. This is Edwards, and this is the space environment. You see, the STC environment is a lot like the space environment, a mostly empty place with extremes of hot and cold, where intelligent life, as represented by a 90% test score or better, is exceptionally rare. Some of you may be familiar with the Jeremy Bearimy concept of time from The Good Place. That is one way of describing our time here. It seemed like each week was its own Jeremy Bearimy, and each test was taken when we were in the dot over the I. 20 Jeremy Bearimys later, and well, you can see why we are so excited to finally be graduating. Along the way, we learned many things about what it means to be a test professional, about the space domain, about each other, and about ourselves. In other words, we studied hard, tested hard, and played hard. We got the opportunity to test out gliders, rockets, antennas, TTP procedures for missile defense, as well as perform a human systems integration exercise, HSI evaluation of NASA crew procedures for the upcoming Artemis missions. As class leader, I led the way by being the first student in our class to test out the Student Improvement Program, or academic probation, or the Smooth Brain Club, whichever you prefer. I think I've figured out the perfect litmus test for future applicants. If someone were to ask me whether they should apply, I think my response will be, do you like STEM? No, do you like all of it? Someone recently asked me what I thought our STC graduate patch means. Other than the obvious distinction of being a graduate of the course, I think our round blue patch is a symbol. To me, the round blue patch represents an institutional investment by the Space Force on the importance of test professionals on par with its investment in TTP professionals. One day, that round patch will turn into a shield and the investment will be realized. But that realization can only come about due to the early buy-in of airmen, guardians, and a few civilians. We are those early adopters. I believe that space will only continue to play a larger role in our nation's geopolitical and astropolitical landscape. I also believe space test professionals will play a critical role in the development of our nation's astronautical capabilities. Graduation means people will now start coming to us, see the patch, and assume we're test experts. But we are not test experts. We are test professionals, part of a large and welcoming test community, and we will be expected to form and maintain professional networks throughout our careers. For my part, I intend to share what I know and seek help when I need it. I'm reminded of a metaphor that someone used to describe what being a TPS graduate represents. Being a graduate doesn't make you an expert at driving, it just means you got your driver's license. To the TPS and STC faculty, I'd like to paraphrase from a previous flight test course. Thank you for the best 5 months we never want to repeat. To my classmates, I say, thank you for creating such a memorable experience. I'll see you out there. And now, I'd like to play our class video.
Please join me once more in thanking Major McLean for all his hard work. The students of STC 23-1 come from a diverse background, representing nearly all space warfighting disciplines, from space system operators and engineers to cyber and program management, and ranging in rank from sergeant to major. Their coursework focused on test fundamentals, system testing, and space sciences, and included an immersive field trip as well as a multi-domain capstone project. The students in Class 23-1 were selectively chosen to be part of this third year of the Space Test course at Test Pilot School. Please join me in a round of applause for the efforts of Class 23-1. And now, for the moment we've all been waiting for, we will now graduate the students of Class 23-1. Major General Dertine and Colonel Pabon, would you please join me for the presentation of the graduate plaques? Graduates, as your name is called, please come to the stage to receive your graduate plaque. First Lieutenant William Chuk. Sergeant Evelyn Davis. Captain Glenn Drum. First Lieutenant Michael Efijuku. Captain Kenneth Ehrenberg. First Lieutenant Austin Esquivel. Captain Helen Janscher. Captain Scott Jones. Major Joshua King. Captain Jimmy Coker. Mr. Matt Lawler. Captain Jacob Lutz. Captain Kelsey O'Brien. Major Christian Peters. Captain Ryan Pinson. First Lieutenant Ryan Radig. First Lieutenant Scott Saha. Captain Caleb Schmidt. Captain Jacob Song. Mr. Chad Waldy. First Lieutenant Adam Ward. And your class leader, Major Sean McLean. Major General Dertine and Colonel Pabon, thank you.
Ladies and gentlemen, this concludes today's event. On behalf of the graduating class and the Test Pilot School staff, thank you for taking the time to celebrate with us today. Please join me in a final round of applause for our newest group of space test professionals.